Okay, today we're going to be working on quadratics that have an a value not equal to 1, so that means their leading coefficient, the number attached to your x squared term, isn't 1. The same steps kind of apply up until a certain point for what we've worked on so far, so I'll just go through them one more time. First, you have to make sure your quadratic is always set equal to 0, then factor out a GCF. Make sure that you don't just factor out your GCF and let it disappear somewhere into the universe. Make sure it's out front in the parentheses out in front of the remaining polynomial. Then we're going to multiply our a and c value together, and because a isn't equal to 1 this time, you'll actually get a different number than your c value. We'll use our table to identify factors that multiply to AC and add to B, so that's all pretty normal. And then we're going to use this reverse box method. And so I'll just kind of be referencing these steps as I go through the example, okay? So in this example, first we make sure our quadratic is set equal to 0. So I'm going to go ahead and just take my quadratic equation. So my 4x squared minus 19x plus 12. I get it set equal to 0. Then I check to see if I factor out a GCF. There's no number that goes into 4, negative 19, and 12 besides the number 1, so I don't have to worry about a GCF. And then now I'm going to utilize my table that we've seen previously to figure out what multiplies to my AC value and adds to my B value. So here when I do A and C, A is 4, C is 12, so 4 times 12 is 48. And then my B value is right in the middle there, negative 19. So I'm figuring out what multiplies to 48 and adds to negative 19. That might take a little bit of work, but I just happen to know that negative 3 and negative 16 do that. So those are going to be those factors. And so now this is where it gets a little bit, you have to do the extra step. So this pair of factors is what multiplies to AC and adds to B. So now we're going to fill in our box. So over here, I'm going to go ahead and draw a box. Lovely. Okay, my x squared term from my quadratic goes in this first section of the box. So I'm going to get a color. My 4x squared term goes in here. Then my constant term, or my c value, goes in the bottom right-hand corner of the box. So positive 12. Then I fill my factors in the other two spaces with x's on them. So my negative 13 and my negative 6 that I just found are going to go in my other two parts of my box with x's on them. So negative 3x and negative 16x. And it doesn't matter which one you put where. So negative 16 and negative 3 could have been switched, and that would have been fine. Now what we're going to do is we're going to find GCFs of each row and each column. So I'm going to start with my columns, and I like to just draw arrows up. So I'm going to find the GCF of each of those columns. So on this far right column here, the GCF between 12 and negative 16 is the number 4. And then one note you want to make for yourself somewhere on the page is the closest box to the GCF section determines the sign that you pull out. So for example, between this 12 and this negative 16x, this box is what's closest to where I'm pulling out GCFs. So I actually need to pull out a negative 4 because this box is negative, the box that's closest, okay? So then in the next column, between 4x squared and negative 3x, I pull out just an x, and that is positive because my box that's closest to that section is positive. All right, now I'm going to go ahead and pull GCFs out of each row. Okay, so in this top row, I have 4x squared negative 16x, so I believe I can pull a 4x out of there, and it's positive because this closest box is positive. And then between negative 3x and 12, I can pull out a negative 3, and it's negative because the closest box to it is negative. And so now I've gone ahead and I've found my factors. So back over here, this quadratic factors into 4x minus 3 and x minus 4. And then now what I'm going to go ahead and do is I'm going to set, because we're solving, I'm going to set each of these factors separately equal to 0 and then solve. So if I'll do my x minus 4 equal to 0 right here. That's 4. So x equals 4 is one of my answers, one of my solutions. And then I take my other factor, 4x minus 3, set that equal to 0. Add 3 to both sides. I get 4x equals 3. Oops. And then I divide by 4 on both sides. So then I get x equals 3/4 is my other solution. My other x-intercept, my other root. Okay, so it's very similar to how you actually solve, right? Get it set equal to 0, pull out a GCF, factor, set your factors equal to 0, and then solve for your x-intercepts. The hardest part here is factoring, and so we've tried to give you a system to kind of set it up with and to follow along with. So if you want to go ahead and try this example, feel free, or excuse me, this you try, and then I'm going to go through it in a second. Okay, so now I'm going to do it. 2x squared plus 6, or plus x minus 6, get it set equal to 0. Okay, there's no GCF in this, and then I notice that my leading coefficient isn't just an x squared, right? I don't have just one x squared, I have 2x squared, so I'm going to use, this whole thing is called reverse box method. So if you hear me reference that in the other helpful videos for this, that's what I'm using, reverse box method. Okay, so I'm going to go ahead and make my table. So I have to multiply AC together, so negative 6 times 2 gives me 12, and then my B value is 1, so, oh, excuse me, it's going to be negative 12, right? Negative 6 times 2. So what multiplies to negative 12 and adds to 1? Well, that would be a negative 4 and a positive 3. So then I'm going to go ahead and stick those bad boys in the box. Okay, again, I'd put my x squared term up here, and then I put my constant term in the bottom right hand corner, and then I take my factors, so negative 4x and 3x. Again, it doesn't matter which factor goes where, it's still going to work in the same situation. All right, so let's do GCFs from my columns. So from this column, negative 4x and negative 6, I can pull out a negative 2. GCF from the first column, 2x squared and 3x would just be an x, I believe. Then from my rows, I get 2x squared minus 4, so that'd be a 2x. And then 3x and negative 6 would be a 3. And so then these are my factors. All right, back over here, I got 2x plus 3 is one of my factors. X minus 2 is my other factor. And so now I go ahead and separately set them equal to 0 and solve. So x equals 2 is one of my solutions. And then took my other factor, set it equal to 0. So x equals negative 3/2 would be my other solution. Cool. All right, let's go ahead and I got, it looks like 2 more examples, so I'm going to fly through these ones. And by fly through them, I mean just try them at a normal speed. So in this first quadratic, we're going to go ahead and we're going to set it equal to 0, because that's the first thing you always do. So 6x cubed minus 4x squared minus 10x equals to 0. Then I see if there's a GCF, and I notice here there actually is a GCF. I can pull out 2 out of each of these and an x. So I have a 2 and I have an x, and then I have, do your division of your numbers to see what's left over. So I'll have 3x squared minus 2x minus 5, and then I had taken an x out of each of those, so that's why they're all 1 less. Okay, so my 2x is out front as a GCF. Then I have a 3x squared, a negative 2x, and a minus 5. So I notice that this is a quadratic, but my leading coefficient isn't 1. I actually have a number there, so I'm going to use my reverse box method. Make my table. So what multiplies, you're only working now inside your parentheses, so we're going to ignore that 2x to the very end. So I got negative 5 and 3 would give me a negative 15. Then I have negative 2. What multiplies to negative 15 adds to negative 2? Well, that would be a negative 5 and a positive 3. So I can go ahead and make my box over here. Fill in my pieces. So my 3x squared goes in up here. My negative 5 goes down here. My factors with x's go in here. And then we're going to start doing my GCFs. So between 3x and negative 5 would just be a 1. Between 3x squared and negative 5x would be just an x. Oh, I think it changed colors. Sorry. Between 3x squared and 3x would be a 3x. Negative 5x and negative 5 would be a negative 5. And then those are my factors. All right, so now I have my 2x still hanging out. 3x minus 5 and x plus 1. This is why, wow. This is why it's so important to keep your GCF out front, because at the very end, this GCF is actually going to be a factor. So I'm taking my 2x, setting it equal to 0. I'm taking my x plus 1, and I'm setting it equal to 0. And then I'm taking my 3x minus 5, and I'm setting it equal to 0. So divide by 2, minus 1, minus 1. Okay, so two of my answers are x equals 0 from my first one, right? 0 divided by 2 is still 0, so that's one answer. My second answer here, when I subtract 1 from both sides, I get x equals negative 1. And then my last solution would be if I solve this one out. So x equals 5/3. Amazing. All right, go ahead and try this you try. And now I will too. All right, 6x cubed minus 12x squared minus 48x equals 0. I definitely have a GCF of 6 here. So I'm going to go ahead and pull out that 6 and an x, I believe, right? 3, 2, and 1, yep. So then when I divide, when I pull out a 6x, you think of it as division. Divided by 6, divided by 6, divided by 6. So then I have 6 divided by 6 is 1x squared. Then I have negative 12 over 6 would be negative 2x. Negative 48 over 6 would be a negative 8. And then that's, oh, sorry, that's all supposed to be still set equal to 0. My goodness. All right, so I took my GCF out, and then, oh wait, double check yourself here. Did you automatically try to start the box method, or reverse box method, excuse me? You don't need it because you don't actually have a number in front of your x squared. So watch out for that, because you guys go a little crazy and do extra work sometimes. So we can just use regular factoring with this. Since your a value is 1, you just have to figure out what multiplies to negative 8 and adds to negative 2. So I'd have 6x. So let's see. Multiplies to negative 8, adds to negative 2. A negative 4 and a positive 2, I believe. So x minus 4, x plus 2. Well, there you go. Look how easy that was. If you use reverse box method, you'll still get the same answer. You just take the long way around. Okay. Now we separately set each of our factors with nice handwriting equal to 0. And we solve. So divide by 6, add 4, minus 2. So we get x equals 0 divided by 6 is 0. 0 plus 4 is 4. And 0 minus 2 is negative 2. So those are our solutions for that one. All right, if you have any questions, let me know. But other than that, go ahead and practice.